Good evening, everyone. On behalf of KMEA Engineering College and AICTE-ATAL Academy, I extend a warm welcome to the valedictory function of our 6-day online faculty development program on advanced artificial intelligence and machine learning techniques for medical image application, held from 18 to 23rd August 2025. This FDP has truly been a platform for learning, collaboration, and innovation in the field of AI and medical imaging. Now, let us begin today's valedictory sessions. To start the evening, I would like to invite our respected Head of the Department of Computer Science and Engineering, Dr. Rafiq T, Program Coordinator of this other FDP, to deliver the welcome address. Over you to sir.
Hi all, uh, respected Chief Guest Rupsa and respected our Dean of College, Dr. Smita ma'am, and other faculties, dear participants. And first of all, I would like to say thanks to all the participants who are effectively contributed in the last 6-day ATAL FDP program. In AI-based application, AI and machine learning applications, especially in the medical imaging applications. And I will share one slide. Yeah. Slide is visible? Yes. So I would like to share some remarks related to this overall FDP. So the total registration of this FDP is 223. From in-house, like our KME participants is 25, and from around 13 states, people are participated in this wonderful FDP. And these are the different areas, like the people's background, like computer science is around 100 people, and from artificial intelligence, now 9 people, and biomedical, and it's a mix of different engineering background. And in imaging. Yeah, so sorry for the network issue. Now it's audible. Hi all. Yes, okay.
Yes, yes.
Yes, sir.
Okay. Um, I need the permission to share my screen. Please, anyone add me as a host or co-host? Yeah, that's okay. Okay, so I would like to move further with introducing our chief guest, Dr. Rupsa, and she is now working as assistant professor in IIT Madras, and she is also expertise in this medical imaging research and especially the AI related things, and she have enough experience in the field of medical imaging, and she worked with the clinicians, and she published several papers in the reputed international journals, and she already also worked in the Philips. So I would like to, on behalf of Computer Science Engineering Department and KMEA Engineering College, I would like to invite you, Rupsa, to this validatory function first. And
Thank you.
next, I would like to invite our uh, Dean Academics, Dr. Smita. She is also one of the main person who supported for these kind of activities, and she discussed different things of related to this FDP last 2-3 days. Also, she personally messaged me about the activities happening inside these FDPs, and I also noticed that I'm happy that she also attended this FDP in everyday sessions. So that is also one of the showed her enthusiasm and research research interest in these kind of FDPs and fields. So I would, on behalf of Computer Science Department, I would like to invite Dr. Smita ma'am to this event.
Thank you, sir.
And finally, I would like to thank all the participants, all the faculty members who are working with me, and the AICTE and ATAL. So thank you all. Thank you for this 6-day faculty development program to a grand success. Thank you.
Thank you so much, sir, for your warm words and valuable insights. Now we are privileged to hear the valedictory address. For this, we have with us a distinguished academician and researcher, Dr. Rupsa Bhattacharjee, Assistant Professor, Department of Medical Science and Technology, IIT Madras. Dr. Bhattacharjee is an imaging scientist with vast expertise in neuroimaging and stroke assessment, and has also worked as postdoctoral associate specialist at the University of California, San Francisco from 2021 to 2025. She has also contributed significantly at Philips Health System as an MRI application specialist. We are truly privileged to hear from such an accomplished scientist. I now invite Dr. Rupsa Bhattacharjee to deliver the valedictory address.
Thank you for the address. So just a word of note before I start is that I am right now staying at the guest house of IIT Madras, so you might hear me a little bit sketchy here and there. Please let me know if my voice is breaking or if there is any issue. Uh, and I would also like to mention that heartfelt thanks to Dr. Rafiq for inviting me. We go way back. We did our PhDs together in IIT Delhi, and Dr. Rafiq was also at UC San Francisco. We did our postdocs together, so we moved around the same time back to India. So it's really nice to see him organizing this huge faculty development program. This is a huge feat. Okay, so I'll do a little bit of introduction, as in a little bit of background of what I did, and then I'll start with some of the projects. So just so we all know, I did my bachelor's in electronics and instrumentation. That was back in 2011 in West Bengal. I did my master's in biomedical engineering right after that in 2013 from Jadavpur University in Calcutta. And then after that, I was recruited as a MRI specialist at Philips Health System. This part I would like to emphasize a little bit because I know there are a lot of faculties in the panel who are working on medical imaging, biomedical applications, and all of it. So I gained a little bit of experience in Philips. I was almost working for 8 years with them. Primarily, my work was to support the MRI softwares, the MRI scanners or machines that were installed in a lot of hospitals. So if you see that when you work very closely with clinicians, we as engineers often don't understand anything beyond algorithms or anything beyond, AI models and all of that. But when I was working at Philips, what I understood was a completely different perspective. That was the perspective of clinicians, the doctors. What are they looking at when they're looking at medical imaging? It's not just an algorithm for them, but it's more coming from a very clinical diagnostic point of view. So they don't really, to be honest, they don't really care whether we are using a certain kind of, let's say, unit algorithm, or whether we are using, a diffusion algorithm. What they most care about is what's the accuracy, how is the algorithm performing, how can you fine tune the parameter, the MRI parameter, to make the images stand out. They don't really care for very kind of fancy mathematics or algorithm. So that gave me a little bit of perspective on what we should focus as engineers, as engineering faculties as well. So at that point in my PhD, I was primarily working on neuro. So I designed algorithms on MR brain scans, and from that, these were non-invasive scans. So if you can see my cursor, probably not, but if you can see right here on A8 images, the boxes around here, you will be able to see that. Actually, let me pin the annotation if I can. So you can see that we try to non-invasively design, algorithm that can predict acute ischemic stroke penumbra from brain MRI images. And we often work with MRI images in the sense that we think all MRI images are the same. But you must have heard in the previous talks as well that there are many kinds of images. Some of them require contrast injection. Some of them are long and time expensive. Some of them are short, but they give different kinds of information. So in this, we used a non-contrast, also known as non-invasive imaging technique. We also use this technique, the same technique, for glioma gradation. So we were able to use the technique called susceptibility weighted imaging and grade whether a certain kind of brain tumor is grade 2 versus grade 3 versus grade 4, because that will determine how the treatment plan goes on. So again, coming back to the clinician's perspective, the most important thing the clinician was concerned about is that A, whether you require contrast injection for this, and B, whether this can give me as good as a diagnosis that I get from my standard gold standard state-of-the-art technique. So that was something that was very crucial in that. So right after I finished my PhD, I moved to San Francisco, just like Dr. Rafiq. So we were then working at UCSF Radiology, and our primary mentor were different people from physical therapy, musculoskeletal radiology, MRI imaging groups. But we were primarily mentored by Professor Sharmila Majumdar, and she was heading this huge group of musculoskeletal interest. And that was the time I got involved with musculoskeletal imaging and osteoarthritis research. So we were exploring the relationship in knee and hip osteoarthritis, how having hip osteoarthritis makes you kind of prone to have knee osteoarthritis eventually down the line in a few years. And then we were using a lot of machine learning, deep learning, model development, a lot of technical feasibility of how we can utilize the new generation MRI scanners, and all of that. And so in 2024, I was recognized with the ISMRM Junior Fellow Award, as well as the Bruce Hasegawa Award at QCSF. And right after that, I moved to IIT Madras as a faculty. It's just about a month. I moved here, I think last month sometime. So a little bit of introduction on why osteoarthritis. And again, medical imaging has a lot of diseases, a lot of techniques that you can be using, but for today's talk, I'll be focusing on what I did on musculoskeletal imaging. So despite the very high prevalence of osteoarthritis and how it impacts people's mobility, people's lifestyle conditions and all of that, we don't really have a lot of therapeutic options, which mean that we need to diagnose diseases very early, sometimes even earlier than they have started. So if you look at a pathophysiological process, you will see that initially this is a normal joint, but as you move forward to early osteoarthritis, you start to see that from the normal joint, you start to see more subchondral bone plate thickness changes in early osteoarthritis. And then eventually the articular cartilage is completely depleted. So we can use multiple MRI techniques to sort of solve this problem. There are also various risk factors that you can use in the AI model when you are modeling for this. So obesity, age, genetic factors, having some kind of inflammation, your mobility levels, how much effort you are putting on the joints every day, and your biomechanical profile, all of that includes and kind of affects your osteoarthritis risk. So essentially, I was trying to answer 4 of the main questions. How and where does it start? So we were looking at relationships between bone, cartilage, meniscus, muscle, ligaments, all of these tissues. We were looking at role of movement and exercise, whether that improves the disease, because a lot of people say that you should exercise more to keep your joints healthy, or whether that extra load worsens your joint. We also studied a collaboration study where we looked at how does it propagate from one joint to the other. So Rafiq was looking at the hip joint and I was looking at the knee joint. Curiously, it was the same cohort. So we were looking at the same patient, but 2 different joints at the same time and trying to understand what is the impact of one on the other. Also, we were looking at various pain experiences. And when you look at diagnostic tools, there is MRI, but there is also something called PET-MR, which gives you a metabolic profile. So that talks about inflammation and whether your joint is overexerted or not. And then when we talk about MRI, we have morphological MRI sequences, which are essentially grading cartilage thicknesses, but also compositional sequences, T2, T1 row. These are all relaxation mapping techniques that we used. So now I'll take you through a little bit of how we used to do our scanning. So this is how a bilateral knee scanning usually happens. You can see a patient lying into the MRI scanner. They have 2 coils wrapped, and then you will get 2 kinds of images out of that. And then we used to have, at that point, it was a double level VNet technique. So the first technique used to classify the cartilages into 5 main classes. And then we had a 11 class VNet technique that used to classify those 5 classes into multiple subsegments and then also menisci levels as well. Now, when we talk about segmentation, doing a segmentation algorithm alone or working on and this is completely my personal experience, that working on a segmentation algorithm alone is not sufficient in current scenario of medical imaging, because there are a lot of segmentation models available and each model performs more than 90% accurately. So if your model can add up to 91 to 92%, a doctor doesn't really see a value in that. The doctor has to see whether that translates, that small improvement, whether that translates to a bigger value, whether it is affecting the shape changes, whether it is predicting some kind of a node principal component that the previous segmentation model was not able to do. So I would like you to encourage all of you, when you work on segmentation problem, beyond dye scores and just beyond matching and what is the image quality matching, go beyond what's the quantitative MRI value that your segmentation is adding to. So that was something we were doing as well. And then we were also looking at superficial and deep layers. We were looking at the patellar cartilage medially as well as laterally. Other than that, we had something called parametric mapping. This is again a huge area of interest for many of you. Will see that T2 map is quite common, but there are also other kinds of mapping that we had, such as T1 row and T2 star. Eventually, with all of that, we looked at these mapping techniques to kind of predict which is the right candidate for osteoarthritis, who will eventually progress to have osteoarthritis, because if you are prone to osteoarthritis, you will often have higher T1 row values in the cartilages. So that was a clear indicator when we were looking at subjects. We also did a lot of PET-MR scannings where we had SUV maps and then MRI and SUV fuse mapping. So that had segmentation on SUV, segmentation on MR, but also registration, and then finally having the bone and cartilage interface, as you see right here. So in the same image, you can see that there is the bone, the red area that you see right here is bone inflammation, and then CU cartilage degeneration as well. We also did biomechanical profiling, which goes very close with medical imaging. And then I wouldn't take much longer, but all of this is published research. So if any of you are interested in looking into any of these things, please let me or Dr. Rafiq know. We can share the papers if you are interested to go into these things in detail. The other thing I would like to highlight is two other things which are very important area coming up recently. Is one of them is low field, because as we know, MRI scanners are very costly, and India is now coming up trying to look at low cost solutions. So we looked at 0.55 Tesla scanners in comparison with the higher, best quality 3 Tesla, and try to understand whether they can also differentiate between hip osteoarthritis or knee osteoarthritis cartilage changes. And then this is one of our colleagues, Gabby Hoyer. She was working on a very interesting project of knee joint digital twins. So she was working at a US osteoarthritis database where she looked at subjects who have exactly same age, behavioral profile, movement profiles and everything. But some of them will, and their starting baseline point was also very similar, but some of them will progress to have osteoarthritis and some of them not. And this was a huge cohort study, almost about 7,000 patients. This paper is published now, so you can look a little bit into it to understand. This was mostly done to understand how initial point can be same, but who develops to have osteoarthritis and who doesn't. So that was a digital twin study that is often very familiar and famous nowadays on a lot of other domains as well. So that is another study I wanted to highlight. And then with that, I would like to take any questions if you have, and I thank you for your attention. These are again 3 of the teams that I work with. You can probably see Dr. Rafiq somewhere here and me somewhere here. And this is from my Philips days and my IIT Delhi days. Thank you everyone again.
Thank you so much, ma'am, for your inspiring words. Next, it is a time for felicitation. We are honored to have with us Dr. Smita KM, who has over 21 years of teaching and research experience in electronics and communication engineering. She has served in various leadership roles such as Dean, HOD, NPA, and NAC coordinator, and is currently an executive committee member of IETE Kochi Center. May I now invite Dr. Smita K. to address the gathering.
Respected Chief Guest, Dr. Rupsa, organizing committee members, and all the resource persons and dear faculty participants. It is indeed an honor and privilege to address you in the valedictory function of the Adult Faculty Development Program on Advanced Artificial Intelligence and Machine Learning Techniques for Medical Imaging Application. It's a highly impactful topic in today's rapidly evolving world, giving a good understanding of AI and deep learning, which enables faster diagnosis and improved patient outcomes. I attended all the sessions with curiosity, even I am from a communication background. I used to attend at least 2 adult FTPs in a year only from communication and antenna side. It is the first time I engaged fully with AA session because the selection of resource persons for this FTP has been truly commendable. Their expertise and industry-oriented insights have made every session highly informative and engaging, especially the interactive discussions held after each session are very valuable, which encourages our practical understanding of participants like me. I believe this FTP will contribute significantly towards achieving the goal of NEP 2020 by equipping the faculty members like us with cutting edge knowledge and industry perspectives, thereby enriching teaching learning practices and fostering innovation driven education as per the motto of AICTE. I take this opportunity to appreciate the coordinators, all faculty and technical staff of Department of Computer Science, KMEA Engineering College, Kerala, for organizing this FTP in a well-disciplined and well-structured manner. The feedback section is a solid proof for this. I really appreciate all. I am confident that the learning and ideas shared here will inspire us to integrate this into research and academy, ultimately benefiting our students and the society as per the motto of ATAL. Thank you all.
Now, as we move towards the close of this memorable sessions, it is my honor to deliver the vote of thanks. On behalf of KMEA Engineering College and ATAL Academy, I extend my heartfelt gratitude to all who made this FDP and today's valedictory function a success. My sincere thanks to our distinguished chief guest, Dr. Rupsa Bhattacharjee, for her inspiring valedictory address. A very special note to gratitude to our HOD and program coordinator, Dr. Rafiq T, whose vision, leadership, and constant support have been the backbone of this FTP. Sir, your dedication has been a guiding force for all of us. I extend my thanks to Dr. Smita KM for her kind words and encouragement during the function. I also take this opportunity to thank the management, faculty members, and organization committee for their tireless effort in making this program success. And last but not least, my heartfelt thanks to all the participants for your active involvement and participation throughout these 6 enriching days. With this, we come to the closing of the valedictory function. On behalf of the organizing team, I once again thank everyone to being part of this FTP and making its grand success. Wishing you the very best in your future. Thank you.
Thank you all. Thank you for the wonderful FTP. Thank you, Rupsa. Thank you, Smita ma'am. Thank you, Nefla.
Yeah.